Hi, my name is Adnaan Lokhandwala, and I'm Senior Marketing Manager at Power Integrations for home building automation and IoT products. Today, I'll be talking to you about a new product, LinkSwitch-TNZ, and how it can help engineers design compact and efficient power supplies for smart home and home appliances. Fundamentally, LinkSwitch-TNZ is a highly efficient offline power supply switcher, which also integrates the capability to do lossless zero crossing detection. The implementation with LinkSwitch-TNZ can allow you to derive a very simple power supply and can also help you reduce the standby consumption in a bunch of different applications. Let me show you how. So if you look at a typical implementation with LinkSwitch-TNZ, let's look at the AC rectification, the capacitor, and then on the side we have rectifier and the capacitor. So what we are seeing here is a very simple implementation in a non-isolated application where the AC input is fed to the switcher and we are deriving an output voltage, which is then fed to power the microcontroller or the wireless controller or for relay power. Now, the beauty with this implementation is you can design offline power supplies without using custom transformers. You can use an off-the-shelf inductor and derive your power directly from the AC line. With LinkSwitch-TNZ, what we've done is we've added the capability to derive the AC zero crossing signals. And we have two pins. These are high voltage pins, which are rated to 1000 volts. And this allows us to directly interface this to the AC line. So essentially at this point is where you would get your zero crossing signal, which would be a logic signal that can be directly interfaced with the microcontroller or something that can make a smart decision based on the synchronization of the AC line. The beauty with LinkSwitch-TNZ also is that the control scheme that it implements, which is essentially on-off control, allows you to now easily adapt this solution also for different topologies. So I've shown you a non-isolated buck here, but you could also use this for a buck boost, and you could also use this for a flyback application up to 18 watts. So with this implementation, you could be doing a buck design up to 575 milliamps at the output, or you could be doing a flyback, which can cover up to 18 watts of power. And this sits in pretty well with the typical power requirements that when we look at a smart home or a home appliance with the connected capabilities into these new devices. The other interesting piece with the capability that we've added with these two pins is that this can also be used for active X-Capacitor Discharge. So this is a key feature which can help you reduce the standby consumption in an appliance application, which typically have large X capacitors sitting at the input, but are required to put bleeder resistors to meet safety regulations. We have a full set of design tools now available for engineers, including design example reports and reference design kits covering from 0.5 watt to 10 watts. And these include non-isolated and isolated power supplies. Beyond that, we also have support in PI's expert suite of design tools. Thank you for watching. For more information on LinkSwitch-TNZ, go to power.com.